All right, continuing in chapter 10 with the area of polygons. We're going to find the area of trapezoids, rhombuses, and kites today. So a trapezoid, if we remember way back from chapter 6, is a quadrilateral with exactly one pair of parallel sides. So the formula for the area of a trapezoid is 1/2 the height times the sum of the two bases, base 1 plus base 2. So let's look at the great state of Nevada, our neighbors. Nevada is close to a trapezoid, so we can use the formula of a trapezoid to estimate the area of Nevada. So if I twist this around, it's a little bit easier. The bases of a trapezoid are always the parallel sides. So if it's easier for you to look at, we can twist it around like this, and we have a base here and a base here. Doesn't matter which one you make, base 1 or base 2. So our area, 1/2 the height times base 1 plus base 2. The area, 1/2 the height here is the 309. There's our H. Times 511 plus 205. So put that in your calculator. Make sure you can come up with the correct answer. I'll give you a second to try to solve that. Remember to use your order of operations, right? Do the parentheses first. And if you're typing this into a calculator for 1/2, you can always substitute 0.5 in there for that. And remember, our final answer is going to be in whatever our units are squared. So whenever we're finding area, we're finding units squared. So hopefully if we are all checking out, we have 110,622 square miles. All right, so miles square. All right, were we able to get that with our calculators? Good, moving forward. Next. Let's go ahead and use this formula. Now we're given the area, and I want to figure out one of the bases. So our formula here, area equals 1/2 height times B1 plus B2. So what I'm going to do now is make a list of all the variables I have and substitute them in. So area equals 20. H equals 4. And B1 also equals 4. B2, that's what we're going to solve for. I'll put that as. I'm going to take these and drop them in for the appropriate symbols, and then solve. And that B2 That's just our x there. So take a minute to see if you can solve that using algebra. It's just a one-step equation. All right, let's see how we did. So first, I'm going to clean up this right here. Half of 4, just 2. And I forgot to plug in the 20 right here, didn't I? That 20 is going to need to go right there. Equals 2 times 4 plus x. And then I can divide both sides by 2 to undo that multiplication. And I get 4 plus x equals 10. And then subtract 4 from both sides. And I get x equals 6. So B2 equals 6. Fairly easy, just a short algebra equation to solve. So next, let's look at heights and rhombuses. So remember, a rhombus is in fact a parallelogram, so we can use the formula for a parallelogram to find the area of a rhombus. The same can be said for squares and rhombuses. So a rhombus is a quadrilateral with 4 congruent sides. So a rhombus, a quadrilateral with 4 congruent sides. This also makes squares rhombuses. And that being said, we can use the formula for the area of a rhombus for the area of a square as well. And then kites were different, right? Kite, a quadrilateral with 2 pairs of consecutive, remember consecutive, one after another, sides that are congruent. So the formula for both of these is the same. I'm going to find the length of the diagonals, multiply those together, and divide by 2. Multiply those together and divide by 2. I think this, in your note packet, looks a little closer here. So this is 5 here. And this is 5 here, and then this is 13. Yeah, so that matches your note packet right there. One thing we know about both rhombuses, squares, and kites is the diagonals are perpendicular for these ones. So key, diagonals are perpendicular. The diagonals are perpendicular. So that being said, I can easily find the area of this kite. I know if that's 5, this is 5. So diagonal 1 is going to equal 10. And then since diagonals are perpendicular, and this is a right angle, I can pop one of these out and solve for a missing side. So I have this right triangle right here, where I want to solve for this value. And I know this is 13 and this is 5. What tool do I have to go ahead and solve? Pythagorean theorem. Very good. So go ahead and do Pythagorean theorem to find this value right here. It can give us our other values. Take a second, see if we can solve that. Let's set this up. X squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. Subtract 25 from both sides. X squared equals 144. I'm going to square root both sides. Square root of 144. Okay. So this is 12. I can figure out the length of this diagonal. So D2 is going to be 17. 12 plus 5. And then the area, 1/2 10 times 17. So 1/2 of 10 is 5. 5 times 17. The area here is 85. Area here is 85. And am I given units? No, so I'm going to say units squared. So units squared. Fairly straightforward. Questions on that? So let's go ahead and graph these points. We're given that these points form a rhombus. We want to find the area of the rhombus. All right, so everyone has these graphed and labeled. So diagonal 1 right there. BC. I want to use the distance formula to go ahead and figure out the length of that. Remember how I like to set up the distance formula. I'm going to set up a shelf. And what I remember is x's go together and y's go together. We can drop those in. Doesn't matter what the order is. So B, we have 0 and 4. And then C, 2 and 2. Where x's go together and y's go together for those 2 points. So I end up with the square root of -2 squared plus square root of 8. And in simplest radical form, we can say that this is the square root of 2 times 4. And then the square root of 4 is 2. So this is 2 root 2. And some of you probably noticed that this right here, this right triangle, that's an isosceles right triangle too. So I can use 45, 45, 90 special right triangles to find that diagonal. And I get the side length of 2 times the square root of 2 is that diagonal. Next one, diagonal 2. That's going to be this one right here, AD. Let's go ahead and set that one up as well. So use our distance formula again. Take a second, set up your shell. See if you can find the distance between those 2 points. I'll give you a few minutes. Remember, just plug your x's together and your y's together for points A and B. So I'll drop these in. A, -2 and 0. And D, 4 and 6. Now we can go ahead and solve for the distance between these 2 points. So you can always add the opposite here, make it a little bit easier for you. So we get -6 squared plus -6 squared. D equals the square root of 36 plus 36. So D equals the square root of 72. And again, simplest radical form. We have 36 times 2, or 6 root 2. Right? So that's 36 times 2. Square root of 36 is 6, and that root 2. So there's diagonal 2. So now, to solve for my area, I have D1 equals 2 root 2. Diagonal 2 equals 6 root 2. So the area will be 1/2 2 root 2. 6 root 2. So dealing with radicals, right? I can multiply this 1/2 right here, and that's just going to turn to 1 and go away. And then I can multiply the inside, so 1 times 6 is 6. 2 times 2 is 4. The square root of 4 is what? 2. So I end up with 6 times 2. My final answer, the area here is 12 units squared. So we can use, after this lesson, hopefully we can find the area of trapezoids, kites, rhombuses, and another way to find the area of squares. Remember, our midterm is next Tuesday and Wednesday for third period.